This is the brief on the International Space Station. So, the ISS, it's the biggest spacecraft we've ever had, with people living on it all the time. It's this huge joint effort, right? Between the US, Russia, Europe, Japan, Canada. They started building it way back in '98. It's kind of like our main base up in orbit. Okay, let's dive in. First off, this thing is just an incredible piece of engineering. It orbits about 400 kilometers, or, 250 miles above us. And get this, it zips around the Earth at something like 28,800 kilometers an hour. That's 17,500 miles per hour. So fast, it goes around the whole planet in just about 90 minutes. Imagine seeing 16 sunrises and sunsets every single day. Life up there? Well, it's tough because of microgravity. Basically, without gravity, bones and muscles get weak, fast. So astronauts, they have to exercise like 2 hours every day just to stay fit. Second, what's it actually for? Well, the ISS is basically a science lab flying in orbit. It's been a US national lab since 2005. They do all sorts of research, studying how liquids act without gravity pulling them down, growing these perfect protein crystals, which, believe it or not, really helps design new medicines faster back here on Earth. So yeah, the science up there, it actually helps us down here, leading to things like better water filters and medical tech. And finally, the ISS is a super important stepping stone for heading out further into space. It's where we test everything needed for long trips. Think life support, living in tight spaces, stuff we absolutely need for missions to the Moon and Mars. Everything we learn about surviving and working together up there, it's all paving the way for those bigger journeys.
Yeah, the International Space Station is really this amazing example of working together globally. And it's still teaching us so much as we get ready for those next giant leaps into the cosmos.
Imagine for a moment, you're gazing up at the night sky, and somewhere way up there, silently orbiting our planet, there's this incredible, brilliant structure. It's just a technological marvel, really, a testament to human ingenuity and, the pinnacle of international cooperation.
Truly is.
And it's not just a machine. It's like humanity's longest-running offshore experiment, a cosmic home for astronauts, and our premier orbital laboratory, the International Space Station, the ISS.
Yeah.
So for this deep dive, we're not just gonna list facts. We want to take you on a journey through the incredible story of the ISS, how this monumental vision actually became a reality.
Right.
What life is really like for those brave explorers who call it home up there, the groundbreaking science they do, and what it all means for the future of space exploration.
And we've pulled some fascinating stuff, haven't we? Articles, resources, some great insights directly from NASA.
Absolutely. Our mission today is really to extract the most important nuggets, the key insights from these materials, to show not just what the ISS is, but why it matters so much for our future.
Exactly. And in doing that, we hope to uncover the just remarkable human ingenuity and that unparalleled spirit of cooperation that, brought this incredible orbiting outpost to life.
And keeps it thriving, day after day.
Year after year. It really shows what's possible when we reach for the stars together.
It's honestly hard to even wrap your head around the sheer scale and ambition behind it.
Yeah.
Just think about the collaborative effort, right? Building something that complex, that enormous, and so far from Earth.
It's incredible. And what's really remarkable is that the whole idea started way back in the 1980s.
The 80s, wow.
Yeah. And it wasn't envisioned as just, one nation's project.
Yeah.
The idea from the start was a shared orbital laboratory.
Yeah.
So that immediately led to this, unprecedented international partnership. You've got the United States, Russia, Europe, Japan, Canada.
The big players.
5 major space agencies pooling not just money, but their best technology, their engineering know-how, scientific talent from 15 different countries. It was pooling resources on a level that's, frankly, unmatched in history. A global commitment from day one.
Okay, let's unpack that collaboration a bit more. So, planning in the 80s, elements being built around the globe.
Yeah.
But the first modules didn't actually launch until '98, right?
That's right, 1998. But here's the truly astounding part. That station has been continuously occupied by international astronauts since November 2000.
Continuously?
Continuously. Think about that. Over 2 decades of non-stop human presence in space. That fundamentally changes our understanding of, long-duration space habitation. It proves we can do it.
Wow. Okay.
And that continuous presence is really a direct result of its incredibly complex assembly. It's modular.
Right, like Legos in space.
Sort of. But, bus-sized Legos, it definitely wasn't built in a day or even a year. The station was meticulously pieced together over many years. It took 42 separate assembly flights.
Right.
Yep. 37 on the U.S. space shuttles, remember those, and 5 on Russian Proton or Soyuz rockets. Imagine launching each huge piece individually, then docking and connecting them precisely, in zero gravity.
That sounds incredibly difficult.
Oh, it was. The modular design includes specific labs like Destiny, that's the U.S. primary research lab. Then there's Columbus, Europe's science hub, and Kibo, which is Japan's facility for experiments.
Okay.
And beyond the science modules, you've got the living quarters, obviously, and crucial docking areas for all the visiting spacecraft bringing supplies and crew.
Uh-huh.
And they're still adding bits. We've seen commercial modules added like Beam, the inflatable one.
Oh, yeah, the Bigelow module, testing inflatable habitat.
Exactly. Testing tech for future deep space missions. And then there's the pre-shell docking module, that spherical hub they added just back in November 2021. Super important for accommodating more spacecraft.
And you mentioned it's a giant structure. That wasn't an exaggeration, was it?
Not at all. This thing is bigger than a 6-bedroom house inside.
Seriously.
Yeah. It's got 6 separate sleeping quarters, 2 bathrooms, its own gym.
A gym in space.
A gym in space. And the cupola, that incredible 360-degree bay window for watching Earth go by.
I've seen pictures from that. Amazing.
The total mass is staggering, 925,335 pounds. That's over 419,000 kilograms.
Almost 1 million pounds.
Nearly. Imagine the engineering needed to lift all that piece by piece into orbit and assemble it perfectly. It's like a cosmic jigsaw puzzle with gigantic pieces.
And the power needed must be immense.
It is. Those enormous solar arrays, they're longer than the wingspan of an Airbus A380. We're talking 356 feet. Or 109 meters long.
Whoa.
They provide about 75 to 90 kilowatts of power, enough to run maybe 40 average homes back here. It's basically a self-sufficient outpost.
Incredible.
And get this, there are 8 miles of wire connecting its electrical system. 8 miles! And the internal pressurized volume, the living space, same as a Boeing 747, about 12,000 cubic feet. So while space is tight, they actually have a decent amount of room to move around in.
Okay, so we've got this colossal international city orbiting Earth. But what's it actually like for the astronauts living there? The day-to-day reality, living in microgravity.
Yeah, it's a truly unique environment, profoundly challenging. In microgravity, simple tasks we just don't even think about on Earth.
Like what?
Like eating, sleeping, just moving from A to B, they become entirely different experiences. You're floating everywhere.
Right.
Astronauts have to completely adapt. Every aspect of life is different. It constantly challenges their bodies in ways we're honestly still trying to fully understand.
Even sleeping.
Oh yeah. They have to zip themselves into sleeping bags attached to a wall, otherwise they just drift around and bump into things all night.
Huh. And their daily routine sounds intense.
It's incredibly demanding. They follow these really strict schedules. It includes conducting complex science experiments, obviously, but also just constantly maintaining the station. It's a non-stop job keeping everything running.
And the exercise.
Crucial. They have to exercise for at least 2 hours every single day.
2 hours, wow.
And it's not just about staying fit, It's a critical fight against bone density loss and muscle atrophy. Microgravity wreaks havoc on the body. That exercise ensures they can safely return to Earth's gravity. Imagine that discipline.
Day in, day out.
Exactly. And the life support systems. They're engineering marvels, constantly recycling air and water.
That must save a lot on resupply missions.
Huge savings. It reduces their dependence on water deliveries by about 65%. That's a really critical step towards longer missions further out.
Makes sense.
But despite that routine, the challenges are still significant. There's constant radiation exposure they have to monitor. There's the psychological side. Isolation, confinement.
Yeah, I can imagine that's tough.
And the ever-present possibility of something going wrong technically. A malfunction that needs quick thinking, on-the-spot problem solving, often without immediate backup from Earth.
Right. High stakes.
Very high stakes. Yet, time and again, these astronauts just demonstrate incredible resilience, adaptability, and amazing teamwork. It's a continuous testament to our ability to thrive, even in, such an extreme and unforgiving place.
But beyond the challenges, the payoff must be that view, right? The perspective they get.
Oh, absolutely. They get to experience Earth from the most breathtaking vantage point imaginable. The station whips around the planet at 17,500 miles per hour.
Wow.
Completes an orbit every 90 minutes. So they see 16 sunrises and 16 sunsets every 24 hours.
16. That's wild.
Think about that ever-changing view. It's so inspiring, apparently. They've taken over 3.5 million photos of Earth from up there.
3.5 million.
Yep, and for us down here, there's even that Spot the Station app. You can crack it, get alerts for when it's flying over your town.
Oh, cool. I should check that out.
It's a great way to connect, Seeing that little point of light moving across the sky, knowing people are living and working up there, a real piece of humanity in the cosmos.
But, okay, beyond being this, amazing cosmic home, the real engine driving the ISS, its main purpose is the science, right? The research.
Exactly. That's its core mission. It's an unparalleled hub for science, an orbital laboratory providing this unique microgravity environment. It's hosted nearly 3,000 research investigations so far,
3,000.
from scientists and researchers in over 108 countries. It allows for experiments that are simply impossible down here.
Like what kind of things?
Well, studying how materials behave without gravity distorting things can reveal totally new properties. That leads to breakthroughs in everything from, say, metallurgy to medicine.
And the fields are pretty diverse, I gather.
Incredibly diverse. You've got microgravity experiments, for instance. Scientists study how plants grow without gravity vital if we want to grow food on long missions.
Makes sense.
Fluid physics, how liquids behave in weird ways up there. Even growing protein crystals.
Protein crystals. For what?
It's crucial for designing better drugs, understanding complex biological processes. They grow larger and more perfectly in microgravity.
Huh. Interesting.
Then there's all the critical human health research. They're constantly studying how long space flights affect our bodies, the muscle loss, bone density, vision changes.
Right, the stuff we talked about with exercise.
Exactly. And understanding that has direct applications for helping people on Earth. Think about rehabilitation programs, treatments for osteoporosis, muscle wasting diseases. The insights benefit us directly.
Okay.
Plus, they're always developing and testing new materials and technologies, stuff absolutely vital for future space exploration, getting us ready for deeper journeys to the moon or Mars.
And it's not just looking inward, right? They look back at Earth, too.
Oh, absolutely. That's another huge benefit. Its unique vantage point allows for incredible Earth observation. High-res cameras, sensors, they track climate patterns, natural disasters.
Like hurricanes and wildfires.
Exactly.
Yeah.
Hurricanes, wildfires, volcanic eruptions, providing critical, often real-time data for scientists and governments worldwide. It helps us respond better to crises and understand the changes happening on our planet.
And it covers most of the populated world, right?
Its orbital path takes it over 90% of Earth's population. So the images, the data, it's globally significant. It informs everything from disaster relief to farming.
And the tech developed for the station must be pretty cutting edge, too.
Definitely. The technological innovations driven by the ISS program have been remarkable, just pushing boundaries constantly. Think about robotics.
The Canadarm2?
Yeah, the Canadarm2. That 55-foot robotic arm, it has 7 joints, 2 hands or end effectors. It's incredibly versatile.
What does it do?
Everything. Assembling new modules, performing maintenance outside, even giving spacewalking astronauts a ride.
Wow.
And beyond robotics, just the challenge of keeping people alive up there. It's led to huge advancements in life support, waste recycling, communication networks. Each version gets better, more robust, more efficient.
And that tech doesn't just stay in space, does it?
That's the crucial point. These innovations often find their way back down to Earth. Practical applications in things like advanced medical devices, water purification systems used in remote areas, new materials, science impacting all sorts of industries.
Like aerospace, cars.
Exactly. Recognizing this huge societal impact, the ISS was actually designated a U.S. national laboratory back in 2005.
Okay, what did that mean?
It was specifically to open it up more, expand research opportunities for commercial companies, universities, other government agencies, making sure its benefits are accessible to way more people and industries right here.
So after all this, decades of operation, incredible science, what does the ISS really mean for our future? How does this orbiting lab connect to, the bigger picture of human space travel?
Yeah, if we connect it to that bigger picture, the ISS isn't really an endpoint. It's more like a profound beginning. It's a crucial stepping stone, you could say, an indispensable testbed for exploring deeper into space. It has absolutely shown that humanity can live and work in space for long periods. It gives us invaluable experience for whatever comes next. It's basically teaching us how to be an off-world species.
Right. It's playing this really vital, practical role in getting us ready for, say, missions to the Moon and Mars.
Precisely.
By understanding the real challenges of long-duration travel, testing the equipment we'll need, developing sustainable habitats right there. The ISS is laying all the essential groundwork for humanity to venture further out.
It's our proving ground. It lets us fail, learn, iterate, fix things in a relatively safe environment, still close to Earth before we take those bigger leaps.
Okay, so the ISS itself won't last forever, presumably.
No, like all machines, it has a lifespan. But its legacy is already shaping the next era. There are active plans now for new commercial space station.
Built by private company.
Built and operated by private companies. It reflects this really significant evolving landscape in space. All the lessons, the tech, the operational know-how from ISS. It's directly informing how these future outposts are being designed and run.
So it's like the ISS paved the way for a space economy, almost.
In many ways, yes. It's the next logical step in humanity's expansion into the cosmos.
And that, I guess, is the really profound legacy, isn't it? The ISS stands as this powerful symbol. Global collaboration, courage, sheer human ingenuity, dedication.
Absolutely. And it continues to inspire generations of scientists, engineers, kids dreaming of space, pushing us to look beyond Earth's atmosphere, explore the unknown. It reminds us of what we can do collectively.
So we've taken quite a journey today, haven't we? Explored the history, the daily life, the amazing science, the future implications of the International Space Station.
We have.
It really is just an unparalleled testament to human ingenuity and, importantly, international cooperation.
And that journey really illustrates a powerful lesson, I think. The ISS exemplifies what humans can achieve when different nations, different people unite for a common, really ambitious goal.
Yeah.
It's more than just amazing engineering. It demonstrates our capacity for global unity, for perseverance, even when facing extreme challenges. It shows us what's possible when we actually work together across borders.
The ISS reminds us that the sky really isn't the limit when we collaborate, hand in hand across cultures, across disciplines. So maybe a thought to leave you with. What grand, maybe seemingly impossible giant structure could you help build through collaboration and dedication right here on Earth? Perhaps if you look up into the night sky tonight, you might even spot it. Our cosmic home, the International Space Station, silently passing overhead. It's always up there, a beacon of what we can achieve together.